Over the past years, globalization has exposed the European manufacturing industry to a competitive situation in which companies need to innovate products in increasingly shorter development cycles. To improve their product development and production workflows, many companies already draw on specialized software for computer-aided design, simulation, and manufacturing. However, some of these tools need high-performance computing resources, which for most SMEs are too expensive. In addition, the datasets used by the software are often huge and typically sensitive to security. The European research project CloudFlow has addressed this situation with the development of a cloud-based service platform that combines state-of-the-art engineering software with scalable and affordable computing resources. André Stork, the project coordinator from the Fraunhofer Institute for Computer Graphics Research, explains the benefits of the platform.
CloudFlow is a European project. It's an innovation action trying to help small and medium-sized enterprises from the manufacturing industry to access and benefit from HPC-based simulation technology. CloudFlow provides the chain from computer-aided design to computer-aided engineering, PLM, data management, up to post-processing.
The results of the CloudFlow project have already been tested in 20 experiments that show the platform's widespread capabilities. Stelba, a German SME working on hydropower plant maintenance, examined how the results of the project can be used to accelerate and improve the design of turbine blades.
Stelba Hydro has been involved in all of the experiments of the first phase in CloudFlow. One of this was a CAD experiment in which we wanted to simplify certain tasks that are needed to design Kaplan runner blades. Due to the rather complex shape of such runner blades, they have quite a lot of operations to design them. So the challenge was to simplify this. By the use of this specific software in the CAD experiment, it's possible to speed up the development process of Kaplan blades. And this automation also helps to avoid errors. So the engineer can focus on his strengths to design Kaplan blades.
BioCurve, a producer of condensing biomass boilers, has worked on the optimization of a biomass boiler design. Together with their partner Nabladot, an expert for computational fluid dynamics, and the University of Saragossa, they have used computational fluid dynamic tools integrated in the CloudFlow environment.
At BioCurve, we design, develop, and market biomass condensing boilers. We have developed and patented the first spiral heat exchanger within the biomass world. The first prototype was somewhat similar to the expected results, but it was not so precise. To improve the prototype, it was a mechanical trial and error process. We changed several variables of the heat exchanger in order to improve it, but only just following our senses, our perceptions. Sometimes the process was frustrating because the results were not the expected ones. So for us, it was very important to meet with Nabladot under the CloudFlow project.
When we first met BioCurve, they were looking for an expert in CFD or fluid dynamics, so they could increase the efficiency of the heat exchanger. So we devised an idea and a workflow to implement the CFD tool in the CloudFlow environment, so that once the project was finished, they could use that tool on their own.
So it was very important for us to have this opportunity, because we simulated lots of different things that we couldn't afford to simulate in reality.
BTEC-C, the Barcelona Technical Center, has worked on an improved thermal simulation process to speed up product innovation in lighting systems. Their experiment was realized together with the Consorci de Serveis Universitaris de Catalunya, CSUC, a high-performance computing provider.
BTEC is an engineering company who provides engineering services to our customers. Most of them belongs to the automotive sector. We provide service of developing products. These products requires a large amount of simulations, and the aim of the experiment was try to increase the performance of BTEC in simulation. The main challenge was to bring the high-performance computing to BTEC. BTEC is in a small and medium enterprise, so resources of computation here are limited. The main benefit from the technical point of view is increasing the number of simulation runs. This means more accuracy in the models and more quality and shortening the time to market.
We have integrated a company that is supporting the exploitation of CloudFlow and is maintaining sustainability. And Glasgow, the name of the company, is taking over the main exploitation of the platform.
Glasgow is bringing CloudFlow into practical reality. On the one hand, Glasgow is acting as a commercial integrator of the technology providers, and on the other hand, Glasgow is empowering end users to customize and to benefit from the solution. We provide engineering apps as a service, and we believe that by using those engineering apps, manufacturers can boost their competitiveness. From the experience in CloudFlow, the end user within the experiments are already forecasting benefits in the range of millions of euros. Our vision is to make this technology accessible and affordable for all manufacturing SMEs.
The impact of CloudFlow for the manufacturing industry will be tremendous. So we see already that the companies that are involved in the experiments will create new jobs in the future in a considerable amount. We try to get more companies on board so that all European SMEs in the manufacturing sector can benefit from CloudFlow and are invited to share our platform.